dropped it. A particle of mass P, a particle P of mass 0.3 kg rests on a rough plane inclined at an angle theta, where sine theta is given to us, okay, is 7/25. Mass is 0.3 kg. Horizontal force of magnitude 4 Newton, okay, we can see that. Okay, everything. Show that the coefficient of friction, the particle is on the point of sliding up the plane, okay. So limiting equilibrium again. So on the verge of sliding up. So friction would be acting downward in this case. So if you break this 4 Newton force into its component, the weight component would be down. The weight component would be 0.3 g sine theta, and this component would be 0.3 g cos theta, and the this angle would also be theta, right? Because this is forming a z. So if this is theta, this is also theta and theta. So this component would, this is also theta. So the component of 4 Newton parallel to the plane is 4 cos theta, and perpendicular to the plane is 4 sin theta. Okay, we have broken it down to all components. So we need to find the F max, definitely friction, which is mu r, which okay, mu, that is what we are trying to find. So mu and n we'll also have to find. N is vertically outward, perpendicularly outward to the plane. So n is equals to 0.3 g cos theta plus 4 sin theta. Sin theta value we already know, it is 7/25. They have given it to us. What about the value of cos theta? 0.3 times g would be 3. Cos theta would be how much? Anyone? It would be 21/25. You can use a right angle triangle over here. Let's suppose this is theta. So opposite upon hypotenuse. So using Pythagoras theorem, we can find the base. Base would be 21. Square 25 squared is equals to 7 squared is equals to base squared. So you will get this base as 21. So now cos theta would be 21/25, adjacent upon hypotenuse. So that's why you replaced over here. So now you use the calculator. 3 times 21/25 plus 4 times 7/25. So n is 3.64. So F max is equals to 3.64 mu. Okay. And now we have to solve for the resultant force to be 0 because it is in limiting equilibrium. And it is on the verge of moving up. So the force is moving up. It is 4 cos theta.
Sir, it will be 24/25, no?
I think I've made mistake in simplification. Let me confirm. Yes, 24, I think. 25 squared minus 7 squared. 24. Good. 24. Sorry. I thought I had it. 24. So 24. Three times 24/25. Plus 4 times 7/25. So this is 4. 4 mu. So vertically upwards you have 4 cos theta is equals to, downwards you have f max. F max we know it is 4 mu, and downwards you have the weight component 0.3 g sine theta. Anything else? Nothing else. So 4 times 24 over 25 minus 3 times 7 over 25 is equals to mu, and this complete thing divided by 4. This should come out as 3 upon 4. Let's see. I hope so. 4 times 24 upon 24 upon 25 minus 3 times 7 upon 25. Like 3 over 4. We're getting 3 over 4. Okay. All good. Murtaza, Ammaz,
Yes, sir.
difficult or easy? Ammaz, Murtaza?
It's all right. It's not that difficult, not that easy as well.
Okay. Let's see. We'll get to know about that once we'll have the test. Okay, the force acting horizontally is replaced by a force of magnitude 4 Newton acting up the plane, parallel to the. Okay, so now this force is not like this now. It is now parallel to the plane upwards. This is the new force. Find the acceleration of P. So if you change it, if now the force is like this, so we'll find the acceleration. F is equals to ma. Vertical, sorry, parallel to the plane upward, the force is 4 minus friction. Friction would be forcing it, would be trying to stop it, and the weight component as well. So weight component is 0.3 g sine theta, and minus friction. Friction will also try to stop it. So friction is mu r. So mu now we know it is 3 over 4, and n, for the value of n we don't have this component, right? We don't have this component now, because now the 4 Newton force is not parallel to the ground, it is now parallel to the plane. So you won't have the perpendicular component of the 4 Newton force. Okay, so you don't have this. So this is 0.3 g cos theta is equals to ma. M, the mass is 0.3 times the acceleration. So you have formed the equation. Use the calculator. 4 times 4 minus 0.3 times 10 times sine theta. Sine theta we know 7 over 25 minus 3 over 4, 0.3 times 10 times cos theta is 24 over 25. This is the answer, divided by 0.3. So 3.333. This is the acceleration of the particle now. Okay. Starting with P at rest. Okay, starting with P at rest. Initially, the velocity is 0. The force of 4 Newton parallel to the plane acts for 3 seconds and is then removed. Find the total distance traveled until P comes to instantaneous rest. This means that right now, this is for part C. We're doing part C. This was the plane, and this was the this is a ball or something like a particle. Okay, the acceleration, they are telling us that this force of 4 Newton is actually being applied for 3 seconds only. So for 3 seconds, acceleration is 3.33 meter per second square, and after that acceleration is 0. Acceleration won't be 0. What would happen after this one? After this situation? Now the 4 Newton force is removed. What should happen? Anyone? The 4 Newton force is being applied for 3 seconds, and after the 3 seconds, this 4 Newton force has been removed. So what would be the situation after that for the particle?
Deceleration or friction force.
Yes, good. There is now no force which is trying to push it upwards. Now the friction will try to stop the motion. So now for this part, acceleration would be negative. How much negative? We'll have to find that out. And when acceleration would be negative, definitely it would try to stop the particle, and after a certain time, definitely it would be instantaneously at rest, and then it would start coming in down, and then would start coming down, isn't it? If for this part, it is accelerating. After this, for this part, it is trying to decelerate because the force which is trying to push it upwards is now removed. So it would just decelerate up until it reaches a maximum point. Its velocity over here would become 0, and after that it would try to come down. But we just want to find how much distance it is traveling from here till here. So for that part, what are they asking us? Find a total distance. Okay, for total distance. For this part of the distance, s is equals to ut. 2s is equals to ut plus half at square. We can apply this one. Yes. Initial velocity is 0. Time is 3. Half a. Acceleration was how much? 10 over 3. And 3 square. So your displacement for this region comes out as 0.5 times 10 over 3 times 9. 15 meters. Okay. And then this force has been removed. So now the new acceleration would be F is equals to ma. There is no force now which is trying to push it upwards. So this 4 Newton force is now 0. So you have the weight component which is trying to stop it, and you have the frictional component which is trying to stop it. So minus 0.3 g sine theta minus 3 over 4 0.3 g cos theta is equals to 0.3 a. So look, now your acceleration would come out as negative. So negative 0.3 into g into 7 over 25. We don't have much time. Times 0.3 times g times 24 over 25. So minus 3. So this answer divided by 0.3 minus 10. Acceleration is now minus 10 meter per second. So how much distance is now traveling in this part? Velocity over here would be 0. Velocity over here, we don't know. We can find it out. V is equals to u plus at. So V is equals to 0 plus 10 over 3 times 3. So V is equals to 10. Over here, velocity is 10 meter per second. So 2as is equals to v square minus u square. 2as v square minus u square. S comes out as 100 divided by 20. 5. So for this part, 5 meters. For this part, 15 meters. So total of 20 meters. This is the final answer. Okay.
Yes, sir.
Nadia, Tuba, Murtaza, and Ahmad. This was an interesting question. Difficult one. The last part. This is how you have to think. Okay, all good. I need a yes or no from all of you. Nuba, Nadia.
Yes, sir.
Yes,
Good.
sir.
Okay. I'm going to stop the recording now. Okay, that's it for today's class.